This is geometry, working on circumference and arc length. We know that arc length can be calculated by using a proportion. The arc length is part of the circle. It's the length of it. The circumference is the total around the entire circle. So part of the circle over the total circle. Part distance around the circle and the total distance around a circle. And that's going to equal the arc measure. It's also known as the central angle. It's the degree value of the arc over the degree value of the entire circle. Part angle measure around the circle and the total measure around the circle. So we have two fractions that equal each other. It's a proportion, and we can use that to solve for arc length. So we have 88 over 360. Those are our angle values. Then we have the length of AB, of arc AB, over the total length. Now the total length is the circumference. Circumference is calculated by 2 pi r. So when we cross multiply this, we'll do two steps in one here. We'll say that that's 88 times 2 times 2 is 4, so that's 4 pi. That is still divided by 360. I could have brought that part up. I could have brought the 360 up through cross multiplying, then divided it again. Or I can just leave it down there the whole time. So we're going to take 88 times 4 pi. No, let's say 88 times 4 pi. Still no. Sorry. There it goes. So that's going to be 1105.84, and we're dividing that by 360. This is going to be the length of arc AB. So when we divide this by 360, we get 3.07. These are meters. This is the length of arc AB. This is different than the measure of arc AB. The measure is an angle value. That's what we used to do. We know what the angle value is. The angle of this would be 88. It would be the same as the central angle. But when we're talking about length, the distance, the amount of fencing that it takes to cover that, that is an arc length. All right, we can come over here to the second one and notice that they're asking for the measure. They want to know the measure of arc RS. They want to know the angle value, essentially what the central angle would be. So our formula, you could say, would be the angle over 360 is equaling the arc length over circumference. That's our basic formula. That's the same formula we used over here. The central angle over 360, the arc length over circumference. We don't know what that angle value is. The angle that we're looking for, we call that the measure of RS over 360. The arc length, they tell us, is 38. I don't know what the circumference is, but I can calculate it. 2 pi times 12.3. So I'm going to cross multiply, so the measure of arc RS, which is our angle value, is 38 times 360. And here we're going to say 2 times 12 and 2 times 3. That's going to be 24.6 pi. Again, we can use our calculator. We have 38 times 360. And we're going to divide that. You must use parentheses. You've got to use parentheses when you type in two pieces. 24.6 pi. And the angle value is going to be 177.01. And these are degrees. So what that means is this angle is opening up 177 degrees. The arc compared to the 360 is 177 degrees of it. On the flip side, we're over here looking at this circle. We see that this central angle is 101. If this central angle is 101, we know that the arc measure is 101 degrees. Now, we want to figure out what the arc measure is of ACB. A to C to B. Well, we don't want the 101. So we're going to say that it's 360. It's the whole circle minus the 101. So we get 259. Let's jump on down here right below it, and we're going to talk about the arc length of ACB. The arc length of ACB is going to be the angle over 360, which is going to equal the length of ACB over 2 pi r. That's our formula that we've been using. We know what the angle is. It's 259 degrees over 360. So that's a lot of it. That's most of the 360. The arc length. How much fence line are we going to use when we come all the way around our circle? Everything but 101 degrees worth. But what's the length? So that's what we're trying to figure out. The length of ACB, our circumference is going to be 2 times pi times 24.9. Well, we have our 259 times that number. 24.9 times 2 is actually 59.8. 59.8 pi.
It's 49.
Of course, thank you. 49, that sounds better. 49.8 pi over 360. That is going to be the length of our ACB. Now we can go to our calculator. We type in our 259 times 49.8 pi. You can figure out that number as 40,000. Now you can write that 40,000 down. I love showing work. 40,520.89. That's going to be divided by pi. That's the length of ACB. So we need to take that number and divide it by 360. And we get an arc length of 112.56. And those would be meters. That was the length of ACB, arc ACB. Sorry I ran right through this question, so we'll slide that question down here. The measure of ABC, arc ABC. Put that down here a little bit lower. We'll come back to that one. Okay, we'll jump back up. Now, what is the measure of CB? Well, you do need to recognize something. CB would be right here. We're not sure what that angle value is, that degree value. But since the angles themselves are congruent, this one is congruent to that one. The total was 259, and if we divide that by 2, we get 129.5. So this is going to be 129.5, and over here is going to be 129.5. Together, they add up to 259. Add in the 101, and we get to 360 all the way around.
Wait, how did we know that they were?
Good question. Why are they equal? Because the two central angles are both congruent. And if this angle is congruent to that angle, we already know that the measure of the central angle equals the measure of the arc. Remember, it's the measure, it's the degree, it's not the length. Length is something different. Length is like circumference. Measure is like 360. All right. If we want to figure out this arc length of CB, we're going to take the angle value over 360, and that equals the length of CB over the circumference, which is 2 pi r. I'm starting all of these out with the same proportion. So get used to writing out that proportion. We know what the angle is. That's your 129.5. And that's of 360 total. We do not know the length of arc CB. And we need to calculate what the circumference is, which we've calculated it once before. And that's the 2 pi times 24.9. So if we cross multiply, and notice we only need to cross multiply one direction. There's no need to bring the 360 up to the arc length and then divide it again. You're welcome to if you would like to. So this is 129.5 times our 49.8 pi. That would be the circumference. And that's being divided by 360. That is our arc length. Now, before we do this calculation, let's make a prediction of what we think the answer is going to be. In our previous problem, what did we do? In the previous problem, didn't we find out what ACB was? What that total arc length was? This was 112 when it came all the way around. Now we know these two are the same amount. Since their central angles are both 129, we know that their arc measures are both the same. So it's really just 112 divided by 2. That's what we would expect to get here. That would have been the shortcut method to go. But I thought it was good to practice setting up your proportion again. So let's type this in. We've got 129.5 times our 49.8 pi. And if we divide that by 360, we'll kind of do it all at once, we'll get 56.28. And those would be meters. That was half what we had found over here. So that would have been the shortcut. We could have just taken this number divided by 2 and we were done. If you were able to recognize that, you were involved enough to realize that, that would be great. But if you need to recalculate it, that is just fine. And then I'll bring down this number F, which is the length of BAC. Just not enough room to do all these proportions. All right, let's take a look at what this one is. We got to use our eyes, our pencil, our finger, something to figure out this ABC. So we're doing A to B to C. So you can trace it out with your pencil, you can trace it out with your finger, you can trace it out at least with your eyes. Where is the A, where's the B, where's the C? And you're talking about the angle value that goes around the outside. Well, from our previous lessons, that's going to be the same as 101 plus the 129.5. So 101 plus 129.5. That's going to be 230.5, and that's a degree. A measure is going to be a degree. A length is going to be a meter or a foot. It's going to be a length like a circumference. Now we're supposed to find the length of arc BAC. So we look back up top. BAC is being the 101 plus the 129. It's everything but this. So it's the total circumference, not including our 56. That's the shortcut way to do this one. But even if we didn't realize that, and we did angle over 360 equals the length of BAC over 2 pi r, that would be just fine. We know that the arc is going to be 230.5 also. We don't know what the length is. We already know the circumference is 49.8 pi. That's 2 pi times r. We've calculated that a few times already, so I was ready for that one. So we'll cross multiply and have 230.5 times 49.8 pi, and that's being divided by 360. That is the length of BAC, arc BAC. So we'll go to our calculator. The numbers are a little big, so a calculator is very helpful. If you don't have a calculator when you do your assignment, you can at least set it up the way we have. And we'll divide this by 360 to do it all in one step, and we get 100.17. 100.17. These would be meters, and that's the length of BAC. We came on over, we made the adjustments to our assignment sheet, we got rid of the Tuesday, and we brought the A down because there's not an arc length B. I won't be here on Friday. We will do the area sectors tomorrow, and then you'll have some more area sectors on Friday with the worksheet. Yeah.